Okay, good morning class. So today we're going to look at the new topic, which is polynomials. This will lead into, or some call it 3D, the third degree or cubic factorization. Okay. This leads into calculus as well. Okay. So polynomials. So we are told that to factorize a third degree polynomial, a polynomial is an algebraic expression which the power of the variable, let's use x, must be an integer greater than or equal to 0, and the coefficient of the variable must be a constant, which is a real number. Okay, we've dealt with polynomials in grade 9. Okay, you must know that the exponent on the x must be a positive number. It must basically be whole numbers. Okay, the number can't be negative in the exponent, and the number can't be a fraction. Alright, so the factorization of polynomials in this sense, it has to be a natural number, or it's actually a whole number, which includes 0. Okay, but you'll see later on which sums actually affected. This one page 132. Okay, what page one? And here we are given examples of polynomials. Okay, so here we've got 3x squared minus 4x plus 2. It's a polynomial of a degree 2, or the second degree. Okay, and it has 3 terms, as you can see here. This polynomial of 4th degree has 4 terms. Can you see that? This here, is this a polynomial? Yes. So the x's exponent is a natural number, or a whole number, as well as that x's exponent, which is 1. Okay, it's a polynomial with degree 3, which is the highest exponent of x is 3, and has 2 terms. Okay. Division by a variable will not give you a polynomial. The following expressions is not polynomials. As we said, the exponent on x, or on the variable, must be positive. It mustn't be a fraction. Okay. So this is not considered as a polynomial. Okay. So because you have y to the negative 2 here. Okay. Here is not a polynomial, because by the root of x can be written as x to the half. Not so. There are powers that are not positive integers, which is a half and negative half. This is also not a polynomial, again because of this here. That will go into the denominator, which will result in a negative exponent. Okay. Let's carry on. The standard form of polynomials shows the terms of all the possible degree combinations. Okay. For a linear or first degree polynomial, the standard form is ax plus b. This is basically a straight line. Not so. For a quadratic, is a second degree polynomial with the standard form of ax squared plus bx plus c. And what type of graph is this? Parabola. So a quadratic polynomial will result in a parabola graph, whilst a linear expression will go into a straight line. That's what we know already. Okay, so that's just what they're highlighting to us here at this point. So this is the first degree, and it cuts your axis how many times? A maximum of once. This is x to the power 2, and it cuts the x-axis a maximum of how many times? 2 times, twice. Can you see that, people? So if you have x to the power 3, how many times do you think is going to cut the x-axis? 3 times, and so on. But you all agree that this, that's why I'm saying the maximum it could cut is twice. There and there. It could cut once, the turning points on the axis, and it can cut no times as well. but the maximum time it can cut is twice. Make sense? Okay. So let's go here. So here we are told for a cubic or third degree polynomial in the standard form, we got ax cubed plus bx squared plus cx plus d. We'll cut how many times? The x-axis? A maximum of 3 times. Sometimes we cut twice, sometimes we cut once. You see, if you take this graph into account, as you can see, it's cutting 3 times there, thrice. But take the graph and then move it up, how many times will we cut there? 1, 2 times, twice. If I bring it down like that, how many times will it cut? Twice. If I bring it completely down, it will cut once and once. And my question is, what's the maximum amount of times it can cut? It is 3 times, and x to the power 3. And this is the cubic graphs that we're going into. Okay, we're going to sketch this in about a week's time from now. Okay. Exciting things coming from. Nice, between 9 to 15 marks on this question. Okay. As I said, that's the one thing we make sure learners know how to do in paper 1, because it's definite marks you're going to get. Okay. At school, we will seldom deal with polynomials of a degree higher than 3. Okay? We're going to work mainly with x to the power 3 as the biggest. Okay. However, the standard form of a polynomial of the nth degree is a to the axn plus b x to the n minus 1 and cx to the n minus 2 and so on and so on. Okay. Where it goes all the way to s to the x plus t, which is a constant that is, what's his name? If you take that 2 into account, it's linear. If you take what comes between s, before s, r, so rx squared will be in parabola and so on and so on. Okay, but that's just basically the standard form. So if n was 8, that is going to be 8 ax 8 plus bx 7 plus cx 6 plus dx 5 plus ex 4 plus fx 3 plus gx 2. What's after g? h, x, and I. No? That's basically what this is. Okay, but you don't have to memorize that. That is just the standard form. Okay, it's nothing major to be concerned about there if you don't understand what I just said. I'm just showing you that whatever number n is, that is 1 less, and 1 less than that, and 1 less than that, and so on. Till you get to a constant base. And they're showing you that's the standard form. A polynomial function is the rule for determining y given x. Okay. For every value of x, there is one value for y. Where else did you see that? For every one value of x is a value for y. Functions is. Okay. And if you look at this here, is this a function? Yes. Why? Because the vertical line is. What type of function is this? It's a many to one function, as you can see. Okay, it's a many to one. Okay, it's a polynomial, the rule is right. A polynomial is a function where the rule is determined right. So every value for x is a value for y. If y is equal to ax plus b is a linear function, straight line. Y is equal to ax squared plus bx plus c is a quadratic or a parabola, we highlighted that. And y is equal to ax cubed plus bx squared plus cx plus d is a cubic function. Okay. So cubic is x to the power 3, as we are familiar with already. Okay. Functional notation or f of x notation, we've dealt with that before, since grade 10. Not so? We spoke about f of x and functional notation, g of x, r of x, q of x, and so on. Okay. You indicate polynomials by p of x or r of y or q of a, where the symbol in the bracket is the variable of the polynomial. For example, q of a is equal to a cubed minus 2a plus 2. But normally we have f of x equals ax squared plus bx plus c. Not so. Where c is your, where x is your variable there. Okay. Alright. That is what we are already familiar with. Alright. For polynomial functions, y is equal to, so convenient. It is convenient to give each function a name if you are working with more than one function. That's also true. So if you got a parabola and a straight line on a graph, we can just say the straight line or the parabola is f and the straight line is g. It's just easy. Otherwise, we have to, if f and g wasn't there, we would have had said y is equal to ax squared plus bx plus c, and then this is y is equal to mx plus c. So you see how much easier it is just to write an f and a g. You guys understand? It makes life a bit easier, and less information drawn on the graph as shown. Okay. You can do this using functional notation, replacing y with f of x, g of x, h of x. Okay. Then we are told that f of 2 means that all the values, that all the x values are replaced with 2. And f of a plus 1 means to say x is replaced by a plus 1. I think we've done something like that in grade 10 already. Now we're looking at the example 1 on page. This is example 1 on page 133. Example 1 on page 133, we are told if f of x is equal to x squared minus 2x plus 1, find the value of f of 1 and f of minus 3. So write the sum down. Okay, so at this point you guys know what to do here, not so? F of 1 is simply 1 squared minus 2 times 1 plus 1. So what does that give us? 1 minus 2 plus 1, which is 0. Not so? F of negative 3 is going to give you negative 3 squared minus 2 times negative 3 plus 1, which is 9 plus 6 plus 1, 16. You will agree with that? Now you work for me out what f of a is. What is f of 2? Y. And what is f of x plus h? Okay, so what is f of a?